This is the first lesson of week 15. In this lesson, we'll be looking more closely at what's going on inside the processor during the fetch execute cycle. In this lesson, you'll learn what a register is and the names of the key registers. We'll review the jobs of the registers and how they operate together in the fetch execute cycle. You should already know that the memory unit or RAM of a computer consists of millions of memory locations. Each location has an address, which is actually a binary number, and it can store either instructions or data using the von Neumann model. The processor can read data or write data to any location in RAM. A register is a very small area of computer memory inside the computer processor itself. The size of each register relates to the word length of the computer, so typically in a modern computer up to 64 bits long, and the contents of the register can change millions of times a second during the fetch execute cycle. It's extremely quick for the processor to access any of the items in the registers. Each register can store one item, a single piece of data, a single instruction, or a single memory address. In each case, it will be stored in the form of a binary number. Remember what we have learned about the fetch execute cycle. Data and instructions are fetched from RAM to the processor. The instruction is decoded in the control unit and executed in the ALU. The result is then saved back to RAM. Three key registers are involved in this process: the memory address register, the memory data register, and the current instruction register. The MAR stores the address from which data is fetched and stored. The MDR stores the data that is fetched and stored, and the CIR stores the instruction that is to be executed. So let's have a look at this in action. During the fetch part of the fetch execute cycle, the MAR stores the address from which data has to be fetched. The current instruction register stores the current instruction, which is to read from that address. The MAR sends the address to RAM. The CIR sends an instruction signal to RAM. And the data that is needed is read from that address. The data is sent back to the MDR, which now stores the data that is needed for the next cycle. During the execute part of the fetch execute cycle, the instruction that has to be executed is sent down the control bus to the processor, and the data that is needed is sent down the data bus to the processor. Inside the processor, the ALU executes the instruction using the data. And then finally, let's see what happens in the final store phase of the fetch execute cycle. The result ready to be stored is in the processor. The storage location is sent to the MAR. The data which needs to be stored is sent to the MDR. And the instruction in the CIR says store. All this information is sent to the RAM, and the result of the operation is saved in the right location. So that's how the fetch execute cycle uses these three registers. The MAR holds the storage address where data is fetched from and saved to. The MDR holds the data that comes from RAM and is sent back to RAM. And the CIR stores whatever instruction is being executed at that moment. This ties in with what you do when you create a program. You use variable names, which actually just identify memory locations. And in a typical program command, you will assign a value to a variable. The variable name will tell the computer what address to use in RAM, and the data is then saved to that address. So let's look at an example of this in operation. Let's say that the next instruction to be executed is instruction 0001. This address is sent to RAM together with a fetch signal. In location 001, there's an instruction, let's say add 2 to the number that's currently in memory. That address is sent, that command instruction is then sent back and stored in the MDR. So the instruction has been fetched from location 1 and is sitting in the MDR. We've seen that in a modern computer system, the data and the instructions come at the same time into the processor. The instruction part of the signal is split off from the data and sent to the current instruction register. The computer is now ready to execute the instruction. The instruction to add and the data value that has to be added are sent to the processor. Let's say the processor is already storing the number 4. It will add 2 to the current value and get the new result 6. And then finally we need to store this value back into RAM. So the location where it's to be stored, let's say location 2, and the data that has to be stored, let's say 6, are sent to the MAR and the MDR. Everything's now ready to store. The address, the data and the signal are sent to RAM, and RAM will store the value 6 at the set location. The entire operation is now completed. This is a generalization, and as we've seen, there is some variation in how this is done. For example, in a CISC processor, the commands to fetch, add and store will be retrieved as a single instruction, which will also hold the addresses for the data to be fetched and where it has to be stored. In a RISC processor, this will be broken down into single instructions, each of which will do only one part of what we've just seen. But the general principle and the use of the registers is just as you've seen it. So just to recap, the MAR stores the address. That's what the A stands for, Memory Address Register. Every time the computer fetches or stores to and from RAM, the MAR tells the computer where to go to in RAM. The MDR stores the data or the data and instructions that are fetched or stored during the operation. And the CIR stores the current instruction, whatever that is, and sends signals to the rest of the computer to carry out those instructions. So your task is to make notes on the MAR, the MDR and the CIR. Your notes should briefly say what those initials stand for, a quick overview, one sentence will do, of what each of these registers does, and then a quick summary of how they work together during the fetch execute cycle. Okay, well, during that lesson, you will have seen me mention buses, which are the channels that transmit the addresses and data. So let's look a little bit more closely at buses in lessons 15.2. See you soon. Bye for now.